Okay, here's a quick little example involving the fundamental theorem of calculus based off of some information which we already know. So again, our fundamental theorem of calculus says we need f to be continuous on the closed interval from a to b, and if that's the case, then the integral from a to b of f prime of x dx will be equal to f of b minus f of a. So let's look at an example. Let's base it off of a definite integral, which we actually already know how to find, okay? Here's our example. The integral from -1 to 3 of 5 dx. Now, we did this when we discussed the properties of the definite integral. And we were able to figure this one out because we know that this means find the area between the curve and the x-axis starting at a, x equals -1, and ending at b, x equals 3. Well, let's think about what that area, what that region actually is. The function is y equals 5. All right, so let's make a quick graph of this like we did during the properties. Okay, so there's our xy plane, and we know that we're starting at x equals -1, and we're ending at x is equal to 3, and our function is y equals 5, which is this line right here. All right, and so our shape is a poorly drawn rectangle, but a rectangle nonetheless, and we're interested in the area of that rectangle. Okay, now what's the area of that rectangle? Well, the base of the rectangle is 4 units. The height of the rectangle is 5 units. So the area is 20. Okay, and you could figure that out already based off of your knowledge from geometry, based off of what we talked about doing the integrand, 5, times the range. 3 minus 1 is 4. 5 times 4 gives us 20. Okay, now let's solve this a separate way. Let's solve this using our fundamental theorem of calculus. Okay, now the 5 matches up with f prime. Okay, we see the dx, we see the integral from a to b, the integral from -1 to 3. So the 5 matches with f prime. So in other words, 5 is the derivative. So ask yourself real quickly, if the derivative of the function is 5, what would the function be? Okay, again, we're saying f prime of x is equal to 5. What does that make f of x? There we go. I can get out of your way. And yes, you are correct. The function would have some form of 5x. It's actually, we're going to talk more about what f of x has to be in a moment. But would you all agree that the derivative of 5x is in fact 5? Yes, okay. So what we know is that f prime, which is 5, well, that means that f of x is 5x, and we're going to plug those values, b and a, -1 and 3, into the original function. All right, so let's write this again. We've got the integral from -1 to 3 of 5 dx. Okay, and we know that this is equal to, now we have to get to the f function. We're no longer interested in f prime, so we're no longer interested in 5, we're interested in the original function, 5x. So I'm going to do a quick little mid-step here. I'm going to write 5x, and I just got to keep in mind that I'm evaluating this from -1 to 3. So I've got a little closed bracket there, and I've got x equals -1 down here, and I've got x equals 3 up there. And the more I do this, you'll notice that I'm just going to write the 3 and the -1. But for now, I know it's hard to see, but this says x equals -1. That says x equals 3. And that's just my reminder that I need to plug them in. Which one do I plug in first? Well, according to this, I plug b in first. B is the larger number, 3. So here we go. This is equal to 5 times 3, that's my f of b, minus, and now I plug in a. A is -1. 5 times -1. We'll take a look at this arithmetic right here. 5 times 3, 5 times -1. 15 minus -5 gives us our exact same answer as before. The fundamental theorem of calculus allows us to get the answer in the same way that, or not in the same way, but basically it allows us to get the answer, and geometry allows us to get the answer. But if we think about it, not all functions are as simple as this, okay? We're going to have many more difficult functions that are our derivatives, just like 5 was our derivative. Now, we had to go from 5 to the function whose derivative is 5, okay? In other words, we had to take the antiderivative of 5. And we're going to have to take the antiderivative of a bunch of messy derivatives. So before we go any further with the fundamental theorem of calculus, we're going to take a quick timeout, and we're going to really focus on antiderivatives. And that's what these next few videos will be about.